Welcome back to Chapter 12. So this week we're looking at glacial systems. And in our last module, we focused on coastal environments, as you know. We looked at what forms them, we looked at what kind of life they harbor, and finally we looked at hazards, and particularly we looked at sea level rise. So today we're going to talk about glaciers, and we'll do something similar. We'll run through a series of 4 short videos. So what we'll be working on is Part 1, Basics of Glaciers, Part 2, The Anatomy of a Glacier, Part 3, Glaciers and Past Ice Ages, and finally Part 4, we'll be looking at climate change. We'll be looking at our warming planet and disappearing glaciers. So let's go ahead and get started on Part 1, which is the basics of glaciers. Glaciers are oftentimes called slow-moving rivers of ice, so to speak, and they form in areas of permanent snow, and they form by snow that is added year after year for a number of different years. And eventually they transform into a mass of ice. Glaciers and ice sheets cover 11% of Earth's land surface, and throughout our history they've covered different percentages of our surface. So for example, in past ice ages they've covered as much as 30% of Earth's land surface. So there's a give and a take there, and we'll talk about climate a little bit later in this lecture. Now, glaciers are going to form in basically 2 contexts. One would be high latitudes, as you can imagine, where you get very little solar insolation and you see very cold temperatures. And the second would be above snowline, and this would be in high mountains. So we're looking at either high latitudes or high elevations. Now, when we refer to snowline, we're really talking about the lowest elevation where snow survives year-round, which is to say, where the winter snow accumulation can persist or last throughout the summer without melting. We're basically looking at 2 basic types of glaciers. So first we're going to look at alpine glaciers, and then second we're going to look at continental ice sheets. So in looking at alpine glaciers, a glacier that forms in a mountain range is going to be called an alpine glacier. And they're going to form in several different subtypes. We're not going to talk about all of them, but most are going to form up in the mountains in snowfields that are confined by what we call cirque. And that's a bowl-shaped erosional landform that's scooped out at the head of a valley. So you can see 3 cirques here in this image that you see. Now, cirque glaciers will frequently flow downhill, and they will form what we call valley glaciers. And you can see this in the image as well. And valley glaciers are rivers of ice within a valley that was once formed by stream action. So it was initially formed by stream action, and then it gets changed or modified over time as the glacier moves through it. So if you can get several of these different valley glaciers that are emerging from confining valleys, and they merge together at the base of a mountain range, then they'll form what we call a Piedmont glacier. And these are glaciers that are going to spread freely over lowlands. So you've got the glacier that's coming out of the valley, and it is emerging into this lowland area. And they can spread out, and they can be really massive. This is the St. Elias Mountains, this image that you see here. And you can see the sheer size here of this glacier. It's really large. Now, if a valley glacier is to flow all the way into the ocean, it would become what we would call a tidewater glacier. And these glaciers can be seen calving, so that's the expression. And that's when you get this breaking off of ice into the ocean, and this floating ice, of course, becomes what we call icebergs. So here in this image, you can see this column that will break eventually into hundreds of small icebergs. Here's an image of a tidewater glacier in Alaska, and there's a lot of footage on YouTube that you can find of calving events, and they can be either really dramatic or they can be a little bit slow and take place over time. But this gives you a sense of how glaciers are formed in high mountain areas, forming again in what we call cirques, flowing downhill, merging into valley glaciers, and then eventually either at the base of a mountain in the form of a Piedmont glacier, or as a tidewater glacier by the ocean, and how we would eventually see calving in that case. So that's kind of 2 different scenarios in terms of alpine glaciers. Now this brings us to continental glaciers. So continental glaciers, or ice sheets, form in non-mountainous areas of continents. These are much larger than alpine glaciers, And most of the Earth's ice, in fact, is found in two places, and that would be Greenland and Antarctica. Ice sheets are so large that they depress the land below them, which is to say that they push land below them down because they're so heavy. And they vary between about 5,000 and 13,000 feet in thickness. Now, these cover all but the highest mountain peaks in the areas where we find them, which again would be Greenland and Antarctica. Ice covers about 81% of Greenland, and it covers about 90% of Antarctica. Antarctica is on the far right here in this image, and you can see that while Greenland is a huge area for a continental glacier, Antarctica is even larger. And because of this, when you look at all of the ice on Earth, Antarctica is going to contain 92% of it. One of the really cool things about Antarctica is that we know that there are subglacial mountains, which is to say that underneath that huge ice cover, there are mountain ranges. And we found this through radar mapping. And you can see this here in this image. You can make out this very large mountain range. And then you can see these kind of layers that are above it. And that's because this mountain range is buried below 2,000 feet of ice. And some scientists have compared this mountain range to the Alps. Of course, it's totally covered. And because of this, we can't see it. And it's oftentimes called Antarctica's ghost mountains. We found this through radar imaging. You can see kind of an illustration here. And you can see to the right of that a kind of layering of the ice that would be on top, and then below that, the landforms. We also know that there are subglacial lakes. So there are hundreds of freshwater lakes that are underneath this glacial ice. And then there's some big lakes like Lake Vostok. This is a lake that is buried below as much as 12,000 feet of ice. And the lake itself may be as deep as 3,000 feet. Lake Willems is another example. Scientists drilled in 2012 and 2013 for water samples here. They found that there may be some really unique ecosystems here. We're still learning a lot about these habitats. But we did find, or scientists did find, microbes that were found in the absence of solar energy. And so there's some questions to be answered here about what kind of life these lakes contain. Now, in terms of continental glaciers, Greenland's ice sheet is less extensive, as I said before. It's about a fifth of the size of Antarctica. But it does feature some really important glaciers. So this is the Jakobshavn Glacier, for example. This is found in western Greenland. Calving from this glacier may have very well created the iceberg that sank the Titanic all those years back. It's a really large glacier. It's 40 miles long. It's more than 1 mile thick. And one of the unique things about this glacier is that it has grown in the last few years. Now, this is after several years or several decades of retreating. As you can see in the image here, in 2016-17, and then moving on to 2017-18, and then 18 to 19, you see an actual growth here. And this is somewhat rare because in most parts of the world, we're just seeing glaciers retreating. But unfortunately, we know that this is the result of water in a nearby current being colder in recent years, and it's part of a climate pattern that's expected to flip in the future. So it's not a permanent thing. And meanwhile, when we look at the whole of Greenland and the sum total of glacial ice, we are definitely seeing retreating.